Hello, everyone, and welcome to today's Open Teams community event. Open Teams is a single point of contact and procurement for your open source solutions, support, and training needs. Visit openteams.com or reach out to us at connect@openteams.com to learn more. As part of Open Teams' overall mission to sustain and support open source, we are also sponsoring the open source architect community with the goal of providing a dedicated space for experts to connect and collaborate over their favorite open source technologies. To learn more or to apply for membership, visit openteams.com/OSA-community. In today's event, we're going to showcase the open source project TrueNAS. Data is an essential part of any digital system, and so therefore it's also essential to have a place to store that data. For quite some time now, it's been common practice, or at least it seemed to be common practice, to default to storing your data in the cloud. No worries about hardware procurement, maintenance, upkeep, all that gets handled by someone else. Why go to the trouble of rolling your own storage solution when someone else can do it for you? But what if that solution wouldn't actually be all that much trouble, and in reality often give you far more than a cloud vendor could provide? TrueNAS is an open source storage solution suitable for applications of any size and which actually is relied upon by most of the Fortune 500 companies. Today, Chris Moore, SVP of Engineering at IX Systems and Head of TrueNAS Engineering, is going to take us on a tour of TrueNAS, its history, its capabilities, and its ability to meet a wide variety of storage use cases. Chris, welcome. Thank you for being here today.
Hey, really glad to be with you today, Brian. This is fun.
Really appreciate your time. So before we dive into TrueNAS itself, why don't you introduce yourself a bit? How did you start working with TrueNAS?
Oh gosh, so I've been with IX many years now. I think going on 17, 18, somewhere in that range. It's long enough I can't keep track of it specifically, right? But started off with IX working on the PCBSD project back in the day, which was a desktop focused on built on top of FreeBSD. Did that for many years, and then one thing led to another. Started getting more involved in the FreeNAS project, as it was called back in the day, at IX Systems, and then of course that morphed into TrueNAS, and here we are now, 2023, SVP of Engineering, and kind of overseeing all the TrueNAS engineering activities. And just it's kind of scary to look back and just see how much it's changed and how much it's grown, but it's exciting and neat, and just so much potential still yet to come. So it's been a journey, and really looking forward to seeing what the next stage brings.
Awesome. So much good for so many people, and more to come. Yeah.
Mm-hmm. Absolutely. Yeah. That's the one thing about doing software development. You're never bored. There's always the next thing we want to go add, the next feature, the next bit of polish we want to do, and the product just gets better as a result.
100%. So you mentioned TrueNAS used to be FreeNAS. What is that history? Where did FreeNAS come from, and then how did it evolve into TrueNAS?
The funny thing is, when I look at these dates, it makes me feel a little old now. But FreeNAS was started in 2005, way back when, if you can remember those days. On FreeBSD, it was a community project. This was before IX really had any involvement with it, and it was I believe FreeBSD 6.0 for those who have been in the Unix space for a while and remember running some of those older releases. And this was pre-ZFS days, a lot of the things we think of today that make up modern TrueNAS, but it was a really cool community project, and it basically lets you deploy a small software-defined appliance and store your data, did a few protocols. It was pretty slick. And then a few years later, in 2009, if we come down the road a bit, the original developer was going to step away from that project, and that's when IX got involved and adopted the FreeNAS project, if you will, took over the principal development of that. And then, fast forward again, many years down the road, where we went into the kind of rebranding, where we had now a FreeNAS product and a TrueNAS product, and TrueNAS was our enterprise appliance software. This is the thing that came on the box you bought from IX Systems that had all the awesome drives in it. And we went through a bit of a rebranding and a unification effort, where we took those two softwares, because they had diverged over the years, and brought them back into harmony into one software package that could run the enterprise version and the community version all in one go, which was a huge win for us as a company. It reduced a lot of overhead complexities and let us open the door to go do some other interesting things.
Yeah, certainly anytime you can maintain one code base instead of two, you're going to benefit from that.
Any software engineers in the audience know the pain we're talking about. Absolutely. Having one branch is much easier than multiple.
So, I mean, I come into this having a general sense, a pretty good sense of what NAS is, the technology generally. But just to make sure, could you go a bit more in depth into what is NAS? What are the protocols that are involved? What the low-level use cases? Why would you, what would you do, and why would you do it with
Sure.
NAS?
So NAS has typically been network driven storage, right? So if you're interfacing with a NAS in the wild, you're usually speaking a protocol like SMB or your Windows sharing protocol. If you're a Unix and Linux geek, maybe you're on NFS. If you're big into the virtualization space, you've been doing a lot of iSCSI over the years for block storage. And TrueNAS today, we kind of get away from that legacy NAS term. We've redefined a little bit to be network applications and storage, because it does a little bit more than that. Now your storage box can also run workloads on it that then interface with your storage directly and are able to manipulate and transform the bits on disk in different ways beyond just a protocol. Protocols are still super important, though. Those are the standards by which we all play to make it interoperable with all the different systems in your environment. But NAS is definitely expanding, and with what we've been doing in recent years with TrueNAS Scale and adding more support for things like GPUs and compute and Kubernetes and applications, it's just really transforming what you might conceptually think of as a NAS today in a good way. Just gives you a lot more flexibility. And as hardware's gotten more powerful, it's almost like, free money on the table, right? It's like, man, I got all this extra compute and resource. Yeah, I want to run some extra workload on there. It's kind of cool to be able to do that.
Excellent. So things like, is it like things like encryption now that the more modern hardware, like what are the software, the bit modifications that you're talking about there?
Yeah, sure. So if we want to go back in the history again a little bit, one of the biggest wins for FreeNAS back in the day is when we transitioned over to the ZFS file system. That really is the bedrock. When we say TrueNAS, and when people talk about TrueNAS in the wild and a lot of the cool functionality it has, a lot of times they're talking about the file system underneath ZFS and how we expose that to our end users and customers. So ZFS really was kind of the last word in file systems. It's enterprise grade from day one through and through. It's designed to protect you from your hardware, which is out to get you. Because we all know hardware, it has a shelf life. It will eventually fail. It's not a matter of if, it's a matter of when. And ZFS is out there doing everything it can to protect you from losing a single bit or byte whenever that happens. So it's handling all the I guess what you'd consider your traditional RAID layouts and your redundancy and your parity, and it's got built-in checksumming. It's a copy on write file system if we want to get into the geeky elements of it, which is cool. And it just opens up the door to all kinds of things like snapshots, immutability, replications, very fast block level replications. It's quite nice.
Interesting. So a lot of things that with other file systems you'd have to rely on firmware or separate applications or devices, ZFS just handles that natively,
just kind of seamlessly right at the file system layer. So instead
wow.
of relying on a hardware RAID card, we do it's software RAID within ZFS. And so we don't have to trust that card operating properly. ZFS is talking directly to the individual disks or drives or flash in your arrays today and monitoring it, checking for corruption, checking for checksums that don't come back properly, and then doing the right things to rebuild parity, notify you, flag it that disk is starting to get flaky, maybe it's time to replace it, handle the replacement, the rebuild. All that good stuff's happening in the background at the file system level, which is the right place to do it.
It provides a single interface. Now you don't have to worry about querying different hardware or whatnot. You talk to the file system, and it provides that information from a single source.
Absolutely. And if you're coming from a Linux world, maybe you're not super familiar with ZFS, think of it as also having the volume manager built in. Instead of a single disk with a file system on top of it that's mounted in a location, ZFS also lets you create basically the pool, which is all your disks put together into one big storage array. And then from there, you're creating data sets on top of that, which think of those as file systems, and you can make and delete those at will left and right. You don't have to go repartition disks or reallocate storage. It's part of the big storage pool. So you can go and create as many of those, and for different needs, this can be my SMB data set. This is my NFS data set. This is where my applications live. This is my wife's photos here, and you can manage them, set different properties on them, compression levels, all that good stuff. And then on the other side, you have something called zvols, which is block storage. So again, still within the same pool, if I decide later I want to go run VMs and I got some other virtualization that I want to provide iSCSI connections to, I can just go create a zvol, specify a size, and it allocates that right on top of the ZFS pool. Again, not having to worry about the disks or kind of the underlying hardware at that point. It's just more of a logical thing to go and carve it up any way I want.
Excellent. Yeah, I had no idea it was that. Yeah, I'd heard of it, but had no idea it was that extensively featured.
It'll
So,
change your life. It's very robust.
I
Most people
mean,
who start playing with it love it.
it sounds fantastic. So, implementation, deployment. I have one box or 10, or where do I start, and how do
Sure.
how would I go? How would I deploy some TrueNAS?
Sure. So, I mean, if you're coming to us as an enterprise customer and you need enterprise, grade hardware, supportability, and all that, obviously you'll come talk to us at the IX system side. If you're somebody who's trying it out, I have your own hardware and gear. It's free to download at TrueNAS.com. Pretty typical. You'll get a USB image, you boot it, install it, couple screens, type in a default password, pick the boot drive you want to use, that kind of thing. And when it reboots, you'll be brought up into a web interface. So everything is all driven through this nice, angular, very modern looking web interface, which hopefully we'll have some time to show off a little bit later. And from there, you'll go through and start provisioning your storage, creating your initial Z pool, allocating your disks, and then start setting up, what you want to use the storage for, be it protocols at this point or applications, kind of just go through the rest of the setup. But very straightforward. It definitely leans a little bit more towards what I'd call the prosumer side, because this is enterprise grade storage. This will have a lot of knobs and features and bells and whistles, which all have lots of good reasons for being there and let you do really enterprisey things in something you just downloaded free off the internet in most cases, which is pretty cool.
Definitely. So, how does it work? Adding new drives, nodes, remote. I assume from what it sounds like, I assume ZFS is the layer that handles that pretty seamlessly.
Yeah.
Is that?
Well, let me clarify. So ZFS is not a clustered file system, so that will be for a single node, and that's how you would deploy it. So ZFS for each node, and we call that scale up. So in some cases we see systems out there with 1,200 plus drives attached to a single node. So when we say scale up, we mean scale way up. You can make it pretty darn big. But that's the one way you operate it. Then later with TrueNAS Scale, with that addition, we started rolling out some clustering capabilities that uses a different clustering file system that sits on top of ZFS. And that's where you would install multiple scale boxes to begin and then create a logical cluster out of 3 to 4 of those to start. And then that would present an SMB share to your end user application or target.
Okay, so did I jump the gun a bit there, going to clusters?
No, that's fine. Okay. Let's say we'll get to it all eventually. I'm happy jumping around.
Yeah, cool. So, is it? I mean, this is a simple analogy, but if I have a single computer with Hotplug SATA, is adding a new drive to an existing TrueNAS instance, is it more or less that simple?
That's pretty much TrueNAS's bread and butter, right? Being able to hot plug devices and swap drives in and out without rebooting or taking the array offline. So absolutely, yeah, you're going to be able to deploy TrueNAS, get your pool created, and if you need to go add additional storage, you can pop those drives in. TrueNAS in the web UI will notice you have new drives. You'll be able to go extend your pool. That's one way you're able to grow. I don't know how technical in the weeds we want to get, but ZFS has a whole bunch of different layouts you can do as far as like how you group your disks and do parity and redundancy and all that. So depending on what you choose, maybe you're going to grow it with 3 disks at a time and add more capacity and performance. Just to give a really quick overview for people who really want to tune ZFS for performance, ZFS uses virtual devices or VDEVs. And so the more of those you get, the more performance you have. So if you think of it this way, if I have 9 disks, I might do 3 plus 3 plus 3. That way I get kind of 3x the performance that I would out of a single VDEV where I'm limited by the speed of a single device.
Okay. So how about failure modes? If with replication, performance access, what happens when a drive fails or you have a reason to pull one?
Sure. So there's a couple different things you touched on there. So local failure modes, for example, if ZFS notices that a read came back with a bad checksum on a block, it's going to start flagging that. And then in the UI, you're going to start getting alerts. And if it gets bad enough, the device will actually be removed from the pool automatically. And if you have a hot spare set up, that can be then swapped in to start basically taking over the parity from the failed drive. That can all happen in the background without any noticeable impact to your applications. There could be a small performance hit while it's rebuilding with that new disk, but for most systems, if you spec it right, you can do that without even noticing, right? Now the disaster scenario you're talking about, replication, that's more of like we lost the entire unit, the building burned down, it got hit with a flood, which, believe it or not, it happens, and things happen. We live in a crazy world. But in the case of ZFS, having built-in block level replication is really what saves your bacon. The way the replication works, because it's done down at the file system level, you can be assured that every single bit and byte that you replicate is identical on the remote side because it's sent over the wire. The same checksums apply. The remote side's also monitoring those checksums as it imports and reads the data. So you'll be able to detect if your remote side's getting corrupted as well. Maybe that hardware's flaky. But assuming you lost your system 1, you can then basically bring up system 2 and turn on the same sharing services and be right back in business. You can make that the primary node.
Okay, so lots of thought throughout the life of the project on ease of use, performance, robustness, reliability, all of that.
Oh yeah, 100%.
And just, is there any limitation on the types of storage you can use, or is it just if you can plug it in, more or less you can use it?
Well, it runs on generic x86 hardware. So if you have something, a modern anything that's 64-bit these days, so your Intels and AMDs runs great on those. As far as type of storage devices, of course, hard drives, flash, SAS, SATA, NVMe can do all of that. It's very flexible and you can mix and match. There's some options within there to do some kind of hybrid pools. If you think about it, with my spinning disk for the bulk storage, then I can use the flash as accelerators as well. You can even create hybrid pools. ZFS has a lot of caching built in. So there's read and write caches, and that's something we see a lot on the enterprise side where we use faster technology for the write cache. On our big enterprise rigs at IX, we use NVDIMM technology. So your write cache is basically running at the speed of RAM, which pretty darn fast, right?
Yeah.
And then, you do your read caches, and maybe that's an NVMe device, a larger flash device. So definitely a lot of flexibility there, which just gives us a lot of places we can play in.
Indeed. So we had a question come in from an attendee. Thoughts, Chris Parkin, thank you for the question. Thoughts on cloud storage versus on-prem and the future of the balance between those.
Sure. So we're, the industry keeps shifting a little bit here and there, and we see it kind of come and go. There's a pendulum effect. We saw a lot of people move to cloud early on, and then people starting to repatriate their data when they realized how expensive it was, and those OpEx costs kind of got out of control. And because now you can run on-prem and have that kind of enterprise-grade peace of mind and redundancy and safety baked in, it's making TrueNAS more and more popular for folks to deploy in a either on-prem strategy or a hybrid strategy. We see people do both and have a mix. TrueNAS can play in all those spaces. It can be run on bare metal, it can be run virtualized. You could toss it in a cloud instance as well and use that for backup. So it's got a lot of flexibility, but long term, we're seeing that people need performance. They need to be able to get to their data quickly. I need to be able to have it local to me. And of course, that's where TrueNAS is going to shine. You can, put it on your 100 gigabit network and go to town. And, that opens up a lot of options, especially for like high-end media and entertainment or working on 8K video editing. That's really important to have that kind of good latency and high throughput.
Indeed. So you mentioned that the FreeNAS project started out as a BSD based on BSD. Is it still there, or is that the only system that supports it? Or
let's talk about that. Let's talk about that. So FreeNAS originally was started as FreeBSD. It was based on FreeBSD 6, I believe I said, and that was its legacy for many, many years. And then a few years back, we introduced a new addition to the TrueNAS family, if you will, TrueNAS Scale, which is now based on Linux. It's built on top of Debian Linux, specifically for those who are curious what it's built on. Very similar technology. Matter of fact, we undertook an effort which seemed kind of crazy at the time. It was a lot of work, but we made it work, which is making our middleware layers portable so we could run most of the same code on the BSD side that we do on the Linux side. And at the end of the day, they're both managing ZFS pools. One of them's using ZFS on FreeBSD and then ZFS for Linux. We did a lot of work to unify those code bases so they're identical and compatible between each other for people who want to migrate between the different editions. And then when we released Scale, I guess, from the community side, some of the biggest asks and things that solved for them was the ability to get access to Docker images and apps containers. That was a huge ask that we never really had an answer for on the FreeBSD side, and Scale brought that to the table. Plus, it enabled us to go and do clustering and some other technologies that were easier to build into the product on a Linux base. So we have a pretty good mix out in the wild right now. People running the 2 editions. Again, pick what works best for you. We're happy that people just love TrueNAS, and we have both editions in the TrueNAS family, but definitely having the more robust KVM backend for doing virtualization on Scale, that's been a big win. And then being able to go run Docker containers and Linux images, which there are a ton of those that people deploy, and I'm always seeing crazy new ones that people are running. That's a big win as well, because especially in kind of our enthusiast prosumer community, we're seeing more and more people do workloads on the array that goes and transforms the data or manipulates it in some way or indexes it. I mean, heck, for my home system, running, a photo indexer tool so I can back up photos from my phone, not have to be reliant on some big cloud provider and hope they don't delete me.
Right. Yeah. Or, shut off the service with short notice, and you're like, have to scramble to try to recover it or something.
Absolutely.
So in terms of choosing between FreeNAS Core, FreeNAS Scale, what are the main considerations there? What would make it?
So today, 2023, if you're choosing between the two, I guess a couple things I would just point to. If you're doing a pretty traditional NAS workload, you just need high performance iSCSI, for example, or SMB, Core is going to work pretty well for you. If you have a little bit more exotic hardware, and by exotic, I mean, how do I say this nicely? Stuff you've cobbled together. That isn't maybe all nice.
Custom built.
Nice.
It's custom
built. Yes. If you're using more exotic custom built type system, Scale's probably going to be a little bit better bet for you. It'll have a wider variety of hardware and driver support out of box, so it should play well on a wider variety of system builds. And then additionally, if you do anything with apps and virtualization, I would say you probably want to skew towards Scale and use that going forward and standardize on it. You'll just have a lot more options and bells and whistles. For that. Scale will still do your iSCSI, block storage, and NFS and SMB and all that. But it really depends on if you're not doing any of that and running on that. The core software, the BSD side, is very battle tested. We've been working on it for a decade plus at this point. It's highly tuned and optimized, and it's going to provide a good experience. And Scale, of course, relatively the newcomer here. It's only been out a few years now, but we're seeing a ton of adoption and enthusiasm on that side, and it's rapidly maturing as well. So you really do have choices, and we're just excited to see people choose TrueNAS in general.
Indeed. So another question from Chris. Fast forward, looking forward 5 to 10 years. What's the roadmap for TrueNAS look like? What do you see as challenges or features that it needs to bring to the table to keep up with whatever technology or software or whatever?
Well, technology, it's always changing. We're looking at NVMe over TCP. That's starting to happen more in the wild. That's going to need to be brought in at some point. There's a lot of new requirements in different industries around security and compliance. So that's becoming a really big focus of TrueNAS in the last couple years now, to really bring it up to snuff for different industries. And of course, just keeping up with hardware changes. We're moving away from a hard drive world, maybe not as fast as all of us would like, but it's happening, and so that presents a different set of challenges to optimize more for flash-based workloads and going from SATA to NVMe in a lot of cases. That brings changes, and we will have to adapt as well to make TrueNAS still highly performant in both scenarios.
Indeed. So right now, the significant number of large organizations are using TrueNAS in production currently. Talk a bit about the different ways that it's being used, the different applications. I don't even know how to describe it.
Sure.
Give us an overview.
Sure. So I guess we'll just talk some workloads here and kind of what we see out in the wild. But one of the cool things, and I remember one of the guys here a while back used to describe FreeNAS and now TrueNAS as a Swiss Army knife, because it does so much functionality. It can be used in quite a different variety of ways. It's not just block, it's not just file, it can also do objects. So we see people doing it to run S3 locally. So but to give you some specific examples, a lot of media and entertainment. So we see folks, especially in the professional media and entertainment space, are using it for editing and their DaVinci Resolves, and a lot of SMB shares with Macs and Windows and working on media assets. That's definitely a big vertical. We see it in academia for providing, home users directories for students to share and store their files off of their local devices. The home space, if you're a home user, probably one of the biggest things people run on it is Plex, which is, having your own media stored locally. So you have your own collection. A lot of people do that. And another huge one is virtualization. If you're running VMware professionally and have a large virtualization environment, when you go peek behind the curtain, you'll see a lot of TrueNAS sitting on the shelf there that's providing the block storage for those compute nodes. Yeah, we could go into the weeds on, there's probably a lot more niche use cases, but those are going to be some of the primary ones. What we're seeing now is with the addition of scale is a lot more interesting things happening where people are now starting to use apps to do some things to the storage as well, or run things on the array to transform. So that's interesting. We'll see how that develops over time away from just traditional NAS protocols.
So when you say apps, you refer to the software elements on the device side. These are configurable, customizable, pluggable.
Yeah, that would be how you deploy something like Plex, for example. If you're a home user, there's an app store, if you will, and you can go pop in there and say, I want to install Plex, or I need to install a VPN so I can install WireGuard or Zero Tier, or I need to go run Nextcloud. I can host Nextcloud on my TrueNAS storage from my home or my business. Definitely a lot of flexibility, and apps just open up a lot of really unique use cases depending on what you install.
Cool. So one of the big, in the news constantly nowadays is AI/ML. Very, very data hungry, very, very processor hungry application that basically everyone wants a piece of. They want to use it, they want to benefit from it, everything. Is TrueNAS equipped to handle data on that scale? Is it already used heavily? Talk about
absolutely. When I talk to you about the size of some of the systems we see people scaling up to, when you're talking 1,200 drives and 20 petabytes plus, absolutely we can scale up. And TrueNAS in those in that space would mostly be run as storage, maybe not as directly with all your high-end GPU compute resources directly on the array. People tend to still run those on a separate box, but you still got to store that data and all that machine learning output somewhere and the input somewhere. So TrueNAS would definitely be sitting in kind of the storage piece of that today. And if it needs to be fast, it's as fast as you're willing to go get hardware for it. So if you want to go all NVMe, all flash, absolutely, you can make it as quick as you need to. And with our big systems, again, with write caches with NVDIMM technology at the speed of RAM, we can definitely play there.
So this is starting to the AI space, MLOps, data engineering, that sort of thing is starting just to reach more significantly out of my expertise. But if you're going to integrate a TrueNAS storage into a data, like a fully automated data engineering MLOps pipeline, do you know does that pipeline care the nature of the storage, or do you have to be careful in how you configure it? Does your pipeline have to know that it's a TrueNAS system backing it?
Not if you're using a protocol. If it's SMB, it's SMB. That's what TrueNAS is based on standard. So you're going to see an SMB share or NFS or iSCSI or S3. In those cases, again, your client application doesn't necessarily have to know or be aware that it's a TrueNAS. You're just going to pick the protocol that your particular application calls for and is best suited to run with. I'm not an expert in the AI space as well, but it seems like there's a few different ways you could potentially run that there. If your AI application, I'm seeing a lot more people do things with S3 these days, which is kind of cool. So you can definitely do that on TrueNAS, and with scale, you can run S3 clustered as well. So if you need to kind of get scale out, you can definitely do that.
Okay, excellent. So one of the things we had planned for the later part of the event was a brief demo of what the interface looks like, kind of what it can do, what it feels like to use. Before we go to that, is there anything else on TrueNAS itself or in applications and use of it that you'd like to mention before we move to that?
I think we've covered a lot of the bases here, and I'm happy to go give a quick little demo and show everyone what the UI looks like and some of the neat things you can do with TrueNAS.
Cool. Go ahead and share that and take it away.
Okay. me just a second here. Okay, I believe you can see the screen now.
All good.
Okay, so I'm going to be logging into my TrueNAS box here, and we'll start at the dashboard first. So this is a TrueNAS scale box. As you can see, we're running 22.12.3.1. That's the most recent update as when we recorded this video anyway. And this is a pretty modest system, but it's definitely got some storage here. It's about 100 terabytes usable space. This is one of my personal play systems, and it's quite a nice little box. And going in through the different screens here, you can see we have storage management where you can view kind of your data, your layouts within ZFS, your topology, if you will. We can go and look at usage. You can see I've filled this thing up. It's about 30% full. You know, kind of look at disk health information. I can go click on things to view reports. One thing I'll touch on really quick is ZFS has something called scrubs, which is a way of usually weekly going and just checking the integrity of everything on disk just to make sure nothing is bit rotted on you behind the scenes. So we have the ability to set those and monitor those here. You can see my last scrub finished just a couple days ago, no errors. So I'm in good shape. I'm not replacing any disks anytime soon, which is fantastic. And then if we move on to data sets, you go through here. And again, I told you the idea of ZFS being a volume manager as well. This is my top level. And then from within here, I can go and create kind of nested data sets and lay them out in any hierarchy I want. So it really depends on your workflow. Again, this is kind of my play box. So I have a couple data sets for some shares and users and applications. And as you can see, we get some little helpful icons here too that tell you what those data sets are being used for. So in this case, I have some SMB shares set up, and then applications are applications, you know, if that's not obvious. But anyway, all the details over here. You can manage your snapshots. You can get in and set permissions on things. This is very important if you're in a larger enterprise environment. You might be connected to directory services like Active Directory and be able to go in and see who has access to what and do all your administrative actions there. Next step, we have shares here. This is a box where I set up a Plex share. So for testing, again, our number one thing people in the community run, which is great. And then on the data protection side, again, all the tools and tasks you need to go ahead and do backups and backup either to cloud services or backup to ZFS. In this case, I have another ZFS system running, another TrueNAS running that I back up to daily. Network settings, won't spend a whole lot of time there, but on the, this is scale. So one of the big things people love to run on scale is apps. As I mentioned, we have an app store that is rapidly expanding almost every week. We have a whole slew of new applications being added. And as you can see, there's quite a few different logos you may recognize in the list of things that can be deployed. Your net datas for monitoring to your MinIOs for S3 storage, even VPNs. SyncThing is quite popular out in the wild. If you're a home user and you want to run a Terraria server, have at it. You know, my kids in particular run their Minecraft server on one of my TrueNASs. So it's very flexible. The same system that runs enterprise grade software and technology, I can run a Minecraft server on, go figure. But it's really cool that TrueNAS has that level of flexibility. So you could be coming in here and installing a MinIO enterprise version as well. I think that's some of the main things here. Up top, you'll see just, you know, typical UI, your alerts, your power settings, you know, being able to go in and adjust users, viewing jobs that are running in the background. If you have like replication tasks, that's where it'll show me what's running and what the progress is and how much time left. But again, pretty powerful system and all wrapped up in a nice, neat dashboard where I can get in and just keep an eye on my storage.
And this is all part of TrueNAS. This is part of the open source project.
This is all TrueNAS, all open source. It's all up on GitHub. Everybody can look at it. And as we like to say, patch is welcome. So if you see something or you have an improvement you'd love to see land in TrueNAS, we welcome feedback and collaboration from our community.
Excellent. How does, you know, so touching on that a bit, are IX system staff the primary contributors to TrueNAS? Okay, but you do, you get a flow of contributions from the community?
Yeah, we definitely try and be good community open source citizens. So we are contributing back. So when we make changes to ZFS, for example, the file system or some of the other components, we try and, you know, contribute those back to the open source communities from whence they came. And then going the other way, we are of course open to community collaboration as well. So again, because it's all open, it's all on GitHub, You can even build from source code yourself on your own
Mhm.
on your own system. So yeah, we absolutely do welcome collaboration, and we get folks who will go and contribute a new feature or functionality or just a simple bug fix. Might be a one-liner. Even the docs are open source. If you see something in the documentation that isn't clear or you want to expand upon, it's just a pull request away on GitHub. Submitting changes is so easy, and we love, and that's one of our core values here at IX, is just that kind of open source and collaboration element. And we love being able to work with our community in that way.
Excellent. Yeah, a point of personal curiosity. So I was looking through the TrueNAS GitHub organization, saw that the Samba repository there, and I think ZFS in there also.
Yeah.
Are those projects, did those originate? Were those FreeNAS projects and have been part of your organization, so to speak, the whole time?
Yeah. If you're curious how we built it, so FreeNAS over time has been built up of a whole bunch of different open source components. Of course,
Okay.
FreeBSD, ZFS, Samba. Oh gosh, trying to think some of the other big ones. Collect D for usage collection, AFP services, iSCSI is built into FreeBSD, although on the Linux side, it'll be SCST. So we're adopting all these different open source packages. We fork some of them and put them in our TrueNAS GitHub repository. And that's where we build from. That's where we branch, we tag, we do all the stuff just for kind of good software development hygiene. And we do our principal development there, and then in turn go and issue pull requests back to the upstream project when we make interesting changes or bug fixes or whatever it may be, and try and keep as in sync with upstream as possible. But a lot of times you'll look at our ZFS repo and see we're either working on fixes there or merging them back or bringing things in from upstream. It's all very transparent and part of our ethos and how we build TrueNAS.
Excellent. Have there been any protocols or those pieces that have been, like say, I don't even know what a good example is, but a new technology of some kind has come out, whether a new type of drive or a drive with a new protocol or new interface, that there's a new protocol, for example, that has been built from scratch as part of the TrueNAS umbrella, or is it primarily those emerge outside and you weave them in as you need?
It's mostly been us weaving them in as we need, but there will be new hardware and different classes of devices that come to TrueNAS. For example, how we build our enterprise HA appliances. We will go and write the code to do the device drivers that allow the two controllers and one chassis to talk to one another. So you'll look in the source code, you'll see a mix of some things IX has developed to enable certain things. Enclosure management's a good example. So when you buy an IX systems piece of a gear and appliance from us, within TrueNAS, you get a nice enclosure management UI where you can click through and view where drives live physically and get all that alerting. That's things we custom build for our hardware, because it does need a certain knowledge about the hardware and what it's actually running on to provide those kind of visualizations. Whereas you wouldn't be able to do that on a homebrew system where we have no idea the topology of where the disks are. How did you cable those SATA devices to what port? We can't guess that for you.
Well, you didn't feel like writing a deep inference, hardware inference engine into it.
Yeah, it'd be a little rough. Hey, if you think you can come up with one, again, pull requests are welcome.
Not me, but somebody out there.
Somebody else. Somebody maybe smarter than me.
So very cool. That's all the topics I had to cover. Any last items you want to drop in before we wrap?
Just a general sense of this is an exciting time on the TrueNAS side. We're getting ready to go into the beta cycle for TrueNAS Scale Cobia is the code name for the next release. You'll start seeing betas for that drop around the August timeframe. So keep an eye on that. There's going to be a lot of improvements to our UIs for applications and for pool creation to try and find that right balance between ease of use and then some power features for definitely the more enterprise setups. So that's coming. With it comes a newer Linux kernel, so newer support for hardware, which is always good. People are always asking, when's my new onboard GPU going to be supported? So about every 6 to 9 months, we got another release that provides you that bump. A lot of things under the hood. We'd say we haven't really gone through and detailed them all yet, but just keep an eye on that. I'd say you'll see some noise about that here in the upcoming month.
Very cool. And the best place for that to monitor that is the GitHub repo,
would be TrueNAS.com
TrueNAS.com.
usually, and just kind of monitoring our blogs and our releases, and then our documentation page as well. Once we announce beta 1, there will be a very detailed release notes page with all the gory details and all the features and even the Jira tickets if you want to go look at them. So it's quite nice.
Excellent. So obviously, if there's someone from enterprise looking to do an install, IX Systems is who to talk to. For
Absolutely.
someone looking to work directly just to explore TrueNAS, the open source project, where's the good place to go for support on that?
So TrueNAS.com, and we have a community forum on there, and everyone's welcome to participate, ask questions. We also have a very lively Discord server. That's where a lot of people, we set that up a couple of years ago, and I remember thinking at the time, I'm getting old. Discord, what do we use that for tech support now? But no, the community really has exploded on the Discord side, and that's where a lot of like live collaboration and troubleshooting and good questions and answers happen. But then the forums, of course, as well, is the other principal place. And
That's
then
terrific.
if you're a developer type, GitHub's probably your go-to. That's where we'll have conversations on pull requests and can discuss issues.
The development side as
Yeah.
opposed to the support side.
Yeah.
Cool. Well, I think that's all for today's event. Thank you so much, Chris, for taking the time, for sharing all this about TrueNAS with us. I really enjoyed this conversation. And if I can find the time, I will probably be giving it a try myself, because
I want the feedback. Let me know how it goes. I'm really eager to.
If nothing else, we'll switch. I have just a home rolled Minecraft server that might benefit from being on TrueNAS. So we'll see.
Absolutely. Yeah, definitely go give it a spin. And like I said, let me know. I'd love to hear the feedback. It has been a pleasure though today. Really enjoyed this.
Yeah, same here. So thank you everyone for attending. As you probably noticed, we are recording the event and we'll be posting the video on OpenTeam's YouTube channel. Subscribe there to be notified when that video goes up. And if you'd like, feel free to ask further questions and continue the discussion from this event in the YouTube comment thread there. Check out openteams.com to learn more about OpenTeams and our offerings, and we'll see you next time. Thank you very much.